All right, so I got a two-stage Copeland compressor. I know it says Alliance, and I'm going to show you guys something here in a minute. Got a two-stage Copeland compressor I'm going to cut open, see how it operates. Then I have a standard scroll LG that I'm going to cut open and see what it looks like on the inside. So I'm going to show you guys. On these scrolls, let's say your equipment numbers are gone and you can't see anything. If you get this sticker off, which I was trying to wet this sticker up a little bit so it would come off a little bit easier. You peel this main data plate off, guess what? That's a Copeland part number right there. So these are Copeland compressors, even though they're branded Alliance, but it even works on Copeland compressors when these data plates are all failed out. Same thing on the LG compressors and the Bristols. But you peel this off, let's say it's been sweating and you can't see anything. If I can get this to come off. Underneath here is, here I got it coming off a little bit. You can kind of see right there the model and serial of this compressor are protected by this big data tag. And then there's a smaller data tag that's under here. And if you're ever having a hard time finding it on a scroll compressor, just peel this off and you'll find it. See? So I'm draining the oil on this compressor, and there was still refrigerant in here. It's boiling off. Alright guys, so I got this Alliance Copeland compressor right here, and then I have this LG compressor right here. I cut both of them open, drained the oil out and stuff, but I'm going to show you what the point of a two-stage compressor is and how it operates versus just a basic scroll and how the operations work. I did a cutaway on this one to kind of see how the motor and stuff is sitting in there, and we're going to go over why mega ohming scroll compressors is really not a thing that we do, because as you can see, this motor is pretty much right up against the case, and being up against the case like that and oil splashing up, because there's oil all inside here. That oil splashing up is creating some conductivity to the case or the ground. It's not a lot, but you'll read like 4 mega ohms, 6 mega ohms, and you'll think, oh, well, they say on this meter that anything below 20 mega ohms is bad. Not the case in these small scrolls. So I'm going to flip this camera around. I'm going to get a little bit more pointed on these, and then we're going to go over the different operations of how this two-stage compressor works versus this single-stage scroll that just operates at one speed, and what the difference is. Because I've heard a lot of misconceptions of how these two-stage compressors work, and I've heard, oh, there's 2 speeds, magical unicorns, fairy dust, etc. And if anybody that's been in the commercial field or refrigeration, you've seen a two-stage compressor essentially, but we call them digital scrolls, to where it has a solenoid that opens up and feeds gas through and unloads that compressor, but it has a pulsing effect, so that way it can set a certain amount of time, and that determines the capacity of that compressor. But I'm going to flip this camera around, we're going to look at these, we're going to take them apart. I did all the hard work, I drilled the holes, drained all the oil, cut them open, pulled them apart, so that way you guys can see inside. They're still a little dirty. I'm setting this stuff up for hands-on, like tangible stuff for Heat Pump Council here in Arizona. So if you're in the greater Phoenix area and you're an HVAC technician, we have Heat Pump Council, which is through the ELA, which is Electrical League of Arizona. I am one of the Heat Pump Council instructors. We offer different courses and master heat pump options, and also that gives you NAEP credits, BPI credits, and gives you the opportunity to become a Heat Pump Council master. So without further ado, I'm going to flip this around and we're going to look at these, and I'm going to make it a better zoom in image so everybody can see. All right, so we're gonna start with the just single speed, normal scroll compressor. For the most part, most scroll compressors are designed this way. As you can see, there is our stator right here. This is our electromagnetic motor. You see how we have all the different plates in there. These mesh plates are to reduce eddy current, but I see a lot of guys with these Supco megometers that have like little LEDs, and then they'll test these compressors and it'll go below the 20 megohm scale and they'll be like, nope, that's a bad compressor. These compressors are not designed to be mega ohmed. When this is submerged in oil, you see how close this is to this case. There's gonna be some kind of resistance to ground because of this. You're gonna have some insulation factor that you're gonna read. I've had scroll compressors that read around 1.8 mega ohms and they're fine. It's just they're bathed in oil at that point in time. But without further ado, we're gonna zoom out. I'm gonna take the top of this compressor, what we would call a head. This is where all the discharge goes to. So I'm gonna pull it up like right here. So inside here, the discharge gets pumped into here and then flows out of our discharge right here. Now, whenever you hear a scroll whistling or it sounds like it's bypassing, that's from this right here. This is the internal relief of a scroll. So if the head pressure gets too high, that starts to relieve pressure and put it back into the crank. So that way things don't explode and go boom, boom, right? So as you can see, this compressor got water in it, so that's where all that rust came from. This compressor, I believe, was a shorted on one of the windings. Don't quote me on that. I pulled this out of one of our scraps. So this is the top of a standard scroll normally. Then we have this little spring right here, which kind of pushes things up against. This is the top part of the scroll. And I'm gonna pull this apart. I've already loosened all these bolts up. These are called hermetic compressors for a reason, because these are not serviceable. You would not cut one of these open, replace the components inside of it, and re-weld it back up together, because it ain't gonna do anything for you. If anybody ever noticed like welds on the side of the compressor, like these little dimple indents, that's what's actually holding the casing in. So like I was trying to grind it off right here and see if I can get this casing to come apart. It didn't work out in my favor and I gave up and I got tired of it. So we have this part right here we're gonna separate. So as you can see, inside here, that's where the discharge gas flows into. This right here this is the stationary part of the scroll. So then we're gonna pull the moving part out. Oh, there goes my sleeve bearing with the key. So as you can see in here, this right here is the part that moves. This is your orbital part of the scroll. So your suction gas gets sucked into here, and as it compresses around, it pushes it all the way into here and then pumps out through here. This is your discharge check valve inside here. We would call that a discharge cage. But when these two are meshed together, what's happening is this is doing this. It's not going back and forth. I've heard people think that they do this, they oscillate, they orbit around the scroll. So it's kind of hard to tell, but as that turns, it compresses. That is how that part of the scroll works. That is where the compression happens. Then you have your body assembly right here, which holds it all together. And then you have your motor key right here, which slides over the motor shaft. And that is what turns, oh, there goes the bearing or the bushing for the cage assembly. So I'm gonna tip this forward a little bit so you guys can see. Inside here, this is where it's at. Whenever you see those welds on here, like right here, and I believe there's one that's like right here, and then there's one that's right here, those are holding the casing together to keep this sitting in normally. Now, on that 2-stage scroll, I actually took the whole body apart so that way I can pull it out and let everybody see. So that's how a standard scroll operates. As this part turns, there's room for movement and oscillation. This little keyway right here allows that to oscillate back and forth. So when this part right here, if I can get it to find the tone, there we go. This is stiff, can't really turn it. It's locked up, obviously, but you can see how it kind of moves back and forth this way. But as this scroll oscillates like this, because this is what it's doing, it's oscillating like this, that keyway keeps it in line. Here, I can kind of get it to move this way. So that's how a standard scroll works. All scrolls have these little bushings in here to keep the discharge cage assembly together. Find our home. And I'll put that back together later. All right, so let's get into a 2-stage scroll. For those guys that have worked on digital scrolls, these kind of work the same way, but a digital scroll operates in the instance of there's a solenoid valve that is not allowing gas to bypass. And what happens is it pulses that valve open for a certain amount of time, lifts the plates apart, and there's an algorithm they use for whatever controller that determines the valve being unloaded for 2 seconds and being loaded for 15 seconds is 75% capacity. That's kind of how they figure that stuff out. I don't have the exact math with me right now, but we're gonna go ahead and open this one up so we can see. So like the other compressor, I cut the head off, but what nobody sees is there's no spring in here, and here's your internal bypass. So if the discharge pressure gets too high, it bypasses out of here and dumps it into the crank to prevent overloading or pipes bursting and stuff. So we got our top of the compressor out there, same fashion. Our discharge comes into here and comes out through here. Then we get into the actual scroll part. So this top piece right here, this is where I want to talk about what it's actually doing. I'm going to see if I can move this a little bit better. So on these, we have, this is where guys get confused. I'm just going to rotate it like this. Guys get confused and they see these terminals right here and they think that's a second motor in here. What that is for a solenoid valve that's inside this compressor. It's a 3-way valve. On startup, that valve is allowing gas to bypass, and I'll show you how that works. Here's your little plug for your solenoid right here. This part will come out. I kept the bolts tight so I can pull it apart. Let everybody see. There we go. So if you look inside here, there's a little tiny port. That's just to allow a certain amount of gas to flow by. Then I'll pull this assembly up off top and show you how the gas gets down below. This right here is the solenoid. This is the solenoid. What happens is it's letting gas bleed through when it's off. So that way it can unmesh the scroll plates and reduce the capacity of the compressor, which reduces the amp draw. Because let's say in first stage you don't need full capacity and you can run 150 pound suction on 410A and still cool the house down, that's great. If the thermostat needs more, it'll call for second stage, energize the solenoid, stop letting gas escape by, and it will load that scroll up. So this part we'll put back on just to have it in place. But I want you guys to also see there's these little pistons right here. This little piston is allowing the discharge gas to escape down into here and go into the crank. So right here, ported, coming out. When this energizes, it stops allowing that gas to flow through. That's why you have these gaskets inside here that seal up that assembly. This will move with the scroll. This part comes apart right here. So as you can see, you have your little port right there. It's going to allow gas to escape. It's going to allow that scroll plate to lift up. Get these bolts out of here. Get this down into place. Here's our bolts that hold the scroll assembly in place. As far as the components of the scroll, they're identical, like as far as an orbiting scroll goes. So we're going to pull the discharge assembly out and take a look at that. So just like the LG compressor, we had our bushings right here for what hold the discharge assembly in place. Same thing. Discharge flows through the center. But if you guys notice, it's ported right there. It has got a tiny little hole that's allowing gas to get to this point to allow it to come through here to unload this compressor. So, normal fashion, like any other scroll, this part doesn't move. This is your stationary member. So, we're gonna set that down right here. Then we're going to pull out our moving assembly. So if you guys see, this moves right here. This orbits inside here. So it's orbiting to compress. Suction gas comes in through here and then gets compressed all the way around till it finds its way here and then gets pumped out. Well, what happens, see if I can find the home for this. There we go. What happens when this thing's unloaded, essentially, this is lifted up slightly. There is room for this to move up and down. So this isn't fully seated into that plate. So we're going to take this apart, take it out. Here's our guide ring that allows it to orbit inside the casing. Now, this motor doesn't come out. But what I did was, I cut the base so I could pull it out. All right. I'm gonna set it down like that. So, this one, for sure I can tell you was locked up. I know this compressor exactly because I'm the one that diagnosed it. This compressor was drawing LRA when it would go to start up. This shaft, if you see, is not perfectly centered. It's not easy to turn this, but through demonstration, see if I can get the key assembly to go in on this. Where did my bearing go? Right here. So we need our key assembly. Only goes one way. Look at me fumbling. So everyone can see, this doesn't if this were to stay still, it would essentially orbit like this. This part wouldn't move, it'd be the bottom piece. I don't know if you guys can hear it, but it's trying to pump when I'm doing that. When I'm going this way, I can hear the oil trying to push out. This way, it doesn't do anything. So, that is essentially how a scroll works. Now, this would be the part that turns in the compressor. This should move freely. There shouldn't be any resistance. This is what we call our rotor. But I'm having to really crank this one to get it to turn because this bottom bearing failed. This right here would be the top bearing in the motor, and I'll pull that up so you guys can see inside the casing. Get this to the side. Ugh. So inside here is your top bearing. What failed on this one is the bottom bearing is sticking and not allowing it to turn on startup. So right here, this is our assembly for the solenoid valve, the diverter valve to stop the gas from bypassing. So that way this thing can fully load up. And then down inside here is our plug for our power to run the motor. This is why I always tell guys these are not 2-speed motors. This doesn't go to a motor. This goes to a solenoid valve. This right here goes to the motor. And when I was talking about those dimples, this dimple right here and this dimple right here and etc. around the whole compressor, those are caved in to hold these arms in place. This is what holds this member in place and this stator. So I hope everybody gets a little bit of something out of it. If there's more you want me to show you about these, leave a comment. So if there's stuff that you guys want to know more about, you want me to take things apart, I'm more than willing to do that. Like, subscribe to my channel, and if you're in Arizona and you're a service technician or an installer and you're looking to expand and become more informed and more educated and get certified in certain things, check out the Heat Pump Council. It's pretty big out here in Phoenix, Arizona. There's classes that are offered year-round from about the middle of May to end of July. We don't really do any courses because we know everybody's busy. So just check it out, guys. But if there's anything else you want to know about scroll compressors, besides the fact that they're heavy, let me know, and I'll see what I can do to give better information. See, this thing doesn't want to go back together. Ugh, field serviceable, not. So, if there's anything else you want to know, or you want me to tear apart or destroy, let me know. I have no problems doing that. I actually enjoy doing this kind of stuff, taking this stuff apart, seeing how it operates. I've done this probably a handful of times, taking these apart. But if there's anything else you want to know, just let me know. And once again, like and subscribe to the channel. Learn more, leave comments. I have a couple guys that emailed me. This is why I'm pulling these apart. Someone asked about what it looks like inside of a scroll compressor. So this is what it looks like inside of a compressor for a scroll. If you want me to tear apart a hermetic reciprocating compressor, I'll do that. I got plenty of those lying around. Or if you want me to pull apart and show you guys how a rotary compressor operates, we'll do that too. But like I said before, I'm not paid for by anyone. I do get paid through the ELA for teaching at Heat Pump Council and being an instructor, but that's paid on that end. They don't pay for any of this stuff. This stuff is still done out of my pocket, my time. So if anybody wants to see anything, just let me know. I'll see what I can come up with and figure it out. And it's getting hot out there, guys. Drink water and happy HVACing, or for those refrigeration guys, enjoy those rack systems. See everybody later. If you enjoy the channel, like, subscribe, share, comment. Happy HVACing.